Good morning. Today we're going to be finishing off section 4.5. I'm going to do a review of what we've talked about so far in section 5. And then we're going to finish off with one last type of problem. But first, the first chunk of time here, just some review. The first thing I want to review is just the basic idea of how we solve an equation that has powers. So if I were to give you as an example something like x squared minus 2x minus 15 is equal to 0, and I asked you to solve that equation. First thing, the biggest power always tells us how many solutions we're going to get. So the power of 2 here tells us we're going to get 2 solutions. The steps involved in solving a second, third, fourth, fifth, sixth degree equation, we begin by getting 0 on a side, and of course you can see here we have 0 on one side right off the bat. Next, what we do is we change the subtraction into multiplication by factoring. And you guys have now talked about 6 types of factoring, but I'm just going to start you off here with a couple of easy ones. As an example here, we have a trinomial, and trinomials usually want to factor into 2 binomials. So doing FOIL in reverse, we would ask ourselves what firsts could multiply together to get x squared, not much for choices there. Then what lasts could multiply together to get negative 15, but at the same time would have to add up to negative 2. And of course, the way we started this was we created lists looking for numbers that would multiply to get negative 15 and add to get negative 2. So negative 1 and 15 doesn't work, 1 and negative 15 doesn't work, but 3 and negative 5 does. So the correct factor is positive 3, negative 5. And once we have multiplication going on, then we can use the zero factor theorem, which says either the first factor has to be equal to 0 or the second factor has to be equal to 0. So we set our 2 factors both equal to 0, creating 2 little equations. And then, of course, we just solve each of the little equations. So we'd get our 2 solutions, negative 3 and positive 5. All right, so those are the 2 values that make the second degree equation true. All right, we made the factoring a little bit harder by kind of combining the types of factoring that we might need to do. So as an example here, if I gave you 4x to the third equals 36x and asked you to solve that equation, the biggest power, 3, tells us that there's going to be 3 solutions. We need to start by getting 0 on one side, and we don't have that right now. So I'm going to choose to move the 36x to the left-hand side by subtraction, move a positive thing to the other side by subtraction, and then factor. But this time, it's not just one type of factoring, it's 2. We first would have to look for what's common to both of the terms, and here what's common to both terms is a 4x. So take 4x out of 4x to the third, 4x out of negative 36x, we're left with x squared minus 9. Right? Then what's in the parentheses can be factored further because what's inside the parentheses is difference of squares. Right? You have a minus in the middle and 2 things you can take the square root of, so difference of squares. So the square root of x squared, that goes in the first position in each. The square root of 9 goes in the second position in each, and then one of these gets a plus, the other one gets a minus. Okay? Now, instead of having 2 things multiplied together, we have 3 things multiplied together. So just extending the zero factor theorem, that means either the first has to be equal to 0, second has to be equal to 0, or third has to be equal to 0. Giving you 3 simple equations to solve. Move plus 3 to the other side by subtraction, move negative 3 to the other side by addition, and get rid of times 4 by division. So our 3 solutions then are 0, 3, and negative 3. Okay? Unfortunately, with second degree equations, we don't always have things that we can factor. So as an example here, 2x squared minus 3x plus 9 is equal to 0. We run into things occasionally, especially powers of 2, that either are too tough to factor or don't factor at all. And so we need other options. And we've learned two. One is called completing the square, and another is quadratic formula. If you choose quadratic formula, you got to make sure you start with 0 on one side, because the way we started that whole thing out again was beginning with ax squared plus bx plus c is equal to 0, so you have to have 0 on one side. Then the number in front of the squared term is a, the number in front of the x is the b, and the number by itself is the c. And then we can just simply put the numbers into the quadratic formula. So the opposite of b, plus or minus the square root of b squared minus 4ac, all over 2a. And remember, when you put a negative number into a formula, wrap it in parentheses. So the two negatives make for a positive 3. Negative 3 times negative 3 is 9. Negative 4 times 2 times 9. 4 times 2 is 8. 8 times 9 is 72. And then check the signs. Negative 4 times positive 2 times positive 9 would give us negative 72. And downstairs, 2 times 2 is 4. 9 minus 72 is negative 63. And do you know what the square root of negative 63 is? Not the 63, but we should all know that the negative is going to come out as I. So our best answer then is going to be 3 plus or minus the square root of 63I over 4. Okay? So sometimes we have to use quadratic formula. Okay? All right. Other problems we've now worked with, especially when the powers are bigger and bigger, like x to the third plus 3x squared minus 4x minus 12 is equal to 0, right? Because the biggest power is 3, we know that means that has to have 3 solutions. And there's a group of problems where I actually started you off by telling you one of the solutions. So here as an example, what if I told you one of the solutions was negative 3, and I asked you for the other 2? What we've learned is that I start with a synthetic substitution. So I start with the coefficients, 1, 3, negative 4, negative 12. And then I put the number that I gave you as kind of a head start into the division box. So the negative 3, whoop, just goes into the division spot. And we run through our synthetic substitution process by dropping down the first number as is, multiplying 1 times negative 3, and adding, multiplying 0 times negative 3, and adding, multiplying negative 4 times negative 3, and adding. And if we get 0 in the remainder position, that means that negative 3 really was a solution. I wasn't just messing with you. And then when we write down what's left, again, it's called the depressed equation. Because we started with 3 solutions and we took 1 out, what we're going to be left with then has 2. So this is going to be 1x squared, 0x minus 4 is equal to 0. And if we just drop the 0x off of that, we'd have x squared minus 4 is equal to 0, and we can either factor that using difference of squares or move the negative 4 to the other side by adding, and then get rid of the power of 2 by taking the square root. So we get x equals plus or minus. Remember, whenever we take the square root of a number, plus or minus, and the square root of 4 is 2. So the other solutions then would be positive 2 and negative 2. So if I give you a head start, again, I told you that one of the solutions was negative 3. I can then ask you for the other ones, all right? By writing down the depressed equation. Okay? And finally, the last kind of problem we ended with is a problem that has a larger power, like x to the third plus 3x squared minus 10x minus 24 is equal to 0. And I'm going to ask you for all of the solutions. So I'll ask you for all of the solutions. But this time I'm not going to give you a head start. I'm not going to tell you one of the answers. I'm not telling you one of the answers. So what do? You apply the rational roots theorem, which gives us a list of possible solutions. And the way that works again is by taking a look at all of the factors, the numbers we can multiply together to get 24, negative 24, sorry, which would be 1s and 24s, 2s and 12s, 3s and 8s, 4s and 6s, and then divide by all of the factors for the number out front. There is no number out front, so of course that means there's actually a 1 there. So the things you can multiply together to get 1s are 1s. And so when we divide everything by 1, we just get essentially the numerator again. We get plus or minus 1, plus or minus 24, plus or minus 2, plus or minus 12, plus or minus 3, plus or minus 8, plus or minus 4, plus or minus 6. So we get a list, a long list, but it's better than randomly guessing solutions out of thin air. And then to figure out which ones actually work, we write down the coefficients in our problem. So 1, 3, negative 10, negative 24, and we start to test the solutions by putting numbers in the box. And of course, what we're looking for is we're looking to get a 0 in that remainder position. Okay, so if I were to try as an example a 1, let's just see how it works. Drop down the first one, multiply 1 times 1 and add, 4 times 1 and add, negative 6 times 1 and add, I don't get 0. I don't get 0 in the remainder position. So that was a bad guess, a bad place to start. Please remember, don't waste your time with the biggest numbers to start. So don't waste your time with the 24s, the 12s, maybe even the 8s. Start with the smaller numbers, okay? And so I'm not going to waste any more of your time here in this video. One of the solutions that'll work then is negative 4. So let me show you that. Drop down the first number, multiply 1 times negative 4, and add. Negative 1 times negative 4, and add. Negative 6 times negative 4, and add. And you see we do get 0 this time. So therefore we know negative 4 is a solution. Now if we write down the depressed equation, remembering we started with 3 solutions, we took 1 out, which means what we have left has 2. So therefore our depressed equation then is going to be 1x squared minus 1x minus 6 is equal to 0. And what we have remaining then is a second degree equation, which can be solved by sometimes factoring, all the time by completing the square, all of the time by, by quadratic formula. Okay? But I kind of set this one up. I rigged this one a little bit so it does factor. It's a trinomial that does factor. In this case, what firsts multiply together to get x squared, what lasts multiply together to get negative 6, and add to get negative 1. So what works is negative 3 and 2. And when you set each of those equal to 0 and solve, moving negative 3 to the other side by adding, we get positive 3. And moving plus 2 to the other side by subtraction, we get negative 2. So up top there you can see our solutions, negative 4, positive 3, and negative 2. Okay, and that's as hard as it had gotten yesterday. Okay, so the last thing, so that's all all of that should be review. So the first 15 minutes or so here should be just review. But we have one thing left to do, and that is the following. Given the solutions to an equation, find the original equation. Right? So given the solutions to an equation, can you find what the original equation is? Okay? Now to show you this, I'm going to draw a line down the middle of my page here. And on the right is going to be the new problem. And what we're going to do here is we're going to tell you the solutions to an equation. So I'm going to tell you the solutions to some equation are positive 4 and negative 6. And what I'm going to ask you for is the original equation. What equation gives me 4 and negative 6 as solutions? Okay? Alrighty, so keep that in mind. That's what we're trying to do. Now to get there, I want to show you an old problem, something we already know how to do, but we're just going to run through it one more time. We're going to solve a second degree equation. Okay, we've done this actually now many times, but let me go through it again. Right, so to solve an equation like x squared minus 1x minus 20, we start by getting 0 on a side. Right, so I did that for you. Next, we're going to factor, which means change the subtraction into multiplication, and in this case we have a trinomial, so we're going to unfoil this thing by asking what firsts multiply together to get x squared, what lasts multiply together to get negative 20, but at the same time would add to negative 1. And what works is negative 5 and positive 4. Once we have the multiplication, then we set each of the factors equal to 0, creating two little equations from the one big, two little, and then we just simply solve each of the little equations. So our solutions then would be positive 5, and then over here move plus 4 to the other side, negative 4. Okay, that's how we solve an equation. Well, now to do our new problem, to find the original equation when we're told what the solutions are, we're just going to work this problem in reverse. So we're just going to do this problem backwards. We're going to do that problem backwards. And here's how it works. We start by just simply saying, let x equals 4 and let x equal negative 6. So we just start with our two solutions and we set x equal to each. Okay, so that's where we are at the end of our old problem. Next, what we're going to do is take each of our little equations and get 0 on a side. So I'm going to move the plus 4 to the other side by subtraction, which puts 0 on a side. I'm going to move negative 6 to the other side by addition, which puts 0 on a side. Okay, so we started by setting x equal to each of the solutions. Now we've taken each of our little equations and we've gotten 0 on a side. Next, what we're going to do is we're going to take our two left-hand sides and multiply them together. So we're going to take one left-hand side, x minus 4, our other left-hand side, x plus 6, and we're going to multiply those together. And finally, to get the original equation, I FOIL. So I'm going to multiply the firsts, the outsides, the insides, and the lasts together. Usually the O and the I can combine. So my final equation would be x squared plus 2x minus 24 is equal to 0. And that's the equation that would give me 4 and negative 6 as solutions. Okay? So that's our last type of problem for this section. Given the solutions, can you guys find the original equation? Okay? So I'm just going to do a couple more of those and then call it a day. So here's my next example. This one I'm actually going to give you 3 solutions. So I'm going to give you 6, negative 3, negative 1. And I'm going to ask you to define the equation that would give me those 3 numbers as solutions. All right, so same format, we're just going to have one extra. All right, so here we go. We start by letting x equal each of those. So x equals 6, x equals negative 3, x equals negative 1. So we take the 3 solutions and just create 3 little individual equations. Then get 0 on a side for each. So move the 6 across, getting 0 on the right. Move negative 3 across. Oops, sorry, typo. getting 0 on the right, and move -1 across, getting 0 on the right. So we got 0 on the right-hand side of each of those. But right now we still have 3 separate little equations. To create one big equation, we multiply the left-hand sides together. So the x minus 6 is going to get multiplied by the x plus 3, and that's going to get multiplied by the x plus 1. And that creates one big equation. And then what I'm going to expect out of you guys is to do the multiplication. I'm going to ask you to do the multiplication. And I'm going to choose to start with these two. So to multiply those two together, I'm going to FOIL. Not going to worry about this x plus 1 right now. So I'm going to FOIL, so it'll be firsts, outsides, insides, lasts. And when I put the O and the I together, positive 3 and negative 6 is negative 3. And then to multiply the trinomial by the binomial, 3 terms times 2 things, I'm going to choose to distribute. So I'm going to distribute the x to each of those. So x times x squared, x times negative 3x, x times negative 18. Once I'm done with the x, I'm going to pick up the 1 and distribute. So 1 times x squared, 1 times negative 3x, 1 times negative 18. And when I combine the like terms, negative 3x squared plus 1x squared is negative 2x squared. Negative 18x and negative 3x is negative 21x. I would then get the equation x to the third minus 2x squared minus 21x minus 18 is equal to 0. Okay? All right, so that's the last kind of problem, is when we give you the solutions, and we ask you to work backwards to the original equation. Okay, and I have one more example, and then I'm going to call it a day for you. And by the way, after this, then you can go ahead and get to work on the problem set, or continue to work on the problem set. Okay, so last one, if I were to give you 2, 3 plus the square root of 5, and 3 minus the square root of 5. Right, those are the 3 solutions. And I want you to tell me what the original equation is. Again, we start by setting x equal to each. In other words, creating 3 little equations. All right? Get 0 on a side. So move the plus 2 to the other side by subtraction. Getting 0 on the right. Move the 3 and the plus square root of 5 to the other side by subtraction. Getting 0 on the right. And then finally move 3 and negative square root of 5 to the other side. So x plus square root of 5 and 0 on the right. Right, so we get 0 on the right-hand side of each of those little equations. And then to create one big equation, we multiply the left sides together. So we multiply this left side, x minus 2, times this left side, x minus 3 minus the square root of 5. And we multiply x minus 3 plus the square root of 5 together. Okay? And again, what I'm going to ask of you guys is to do the multiplication. And I'm going to choose to start by multiplying the 2 trinomials together. So I'm going to multiply this trinomial and this one. Right? And I'm going to choose to once again use the distributive idea. So I'm going to pick up the x in this one and distribute it to all 3 of the others. So here we go. X times x times negative 3, x times the square root of 5. Okay? Once I'm done with the x, I pick up the negative 3 and do the same thing. Negative 3 times x, negative 3 times negative 3, and negative 3 times the square root of 5. And then finally, I pick up the negative square root of 5 and distribute it to all three. So negative square root of 5 times x, negative square root of 5 times negative 3, and negative square root of 5 times positive square root of 5. A negative thing times a positive thing is negative. Square root of 5 times the square root of 5 is the square root of 25, which turns back into just a plain old 5. And then what we'll end up with is two pairs of opposites, and let me use my highlighter tool so I can show them to you. We have positive x square root of 5, negative x square root of 5. Those are opposites of each other, so they will cancel. We also have negative 3 square roots of 5 and positive 3 square roots of 5. Those are opposites, so those also add up to 0, cancel. And so what we're left with then is negative 3x and negative 3x, 9 minus 5. 9 minus 5 is 4. Okay? So the trinomial times trinomial was kind of ugly, kind of terrible, but it turns out pretty nice. And then to finish, again, I could either use the distributive idea or stack these on top of each other, but I'll just continue with the distributive idea. So distribute the x times x squared, x times negative 6x, x times 4. Then pick up the negative 2 and distribute to all three. So negative 2 times x squared, negative 2 times negative 6x, and negative 2 times 4. And when I put the like terms together, negative 6 and negative 2 is negative 8x squared. 4x and 12x is 16x. My third degree equation then, that gives me those three solutions. X to the third minus 8x squared plus 16x minus 8. Okay? Alrighty, so that's it then for section 5. Now for the second half of the hour, I just want you to work on the assignment, continue to work on the assignment. We'll go over questions on this one tomorrow, turn it in, and then get started on section 6. Have a good day. See you soon.